everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're talking about steps organisations can take to assure performance as they integrate AI more deeply into their IT environments and adapt to the ever-changing AI landscape. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. AI is transforming industries at a rapid pace, yet many organisations are realising that their infrastructure may not be ready to support its advanced workloads. Why is this?
So businesses started with this confidence where they were sort of focusing on strategies and sort of small experimental environments. But then when they actually started to try and scale that up, that's when they hit problems. So they're actually confident of making AI work, but then they actually tried to scale it up. So think of it like you're cooking for a dinner party. So you have sort of 6 friends round. You think you're a great cook, a great chef, then you decide to take that into a commercial one. All of a sudden, you need industrial kitchens and professional equipment. I need sort of completely different process to serve 600 people versus 6. And this is what they started to face. So facing these questions such as, can my infrastructure handle additional AI workloads? What other investments do I need to make? And these are sort of things that's keeping them awake at night. And when you think about this, when we think about what's happening here, the scope is actually, from an infrastructure perspective, is far wider. So we're not just sort of dealing with one particular element. So here we're sort of dealing with on-premises data centers, public clouds, private clouds, and these total hybrid environments. So all of a sudden, the landscape's completely changed. And if you start to layer on top of that data sovereignty, this adds another layer of complexity. So they need to navigate where the AI training data is going to be stored and where it's going to be processed. And if you sort of put the regulations on top of that, cross-border data transfer restrictions, we're really talking about all these different things that come in. That's talking from a general perspective. But if we then come into the verticals where you're considering things like the financial or the healthcare, then we have additional AI infrastructure constraints, due to these data residency types requirements. So we have all of these different things that have to come into place, which is really starting to scare people when they start to look at these workloads, because this is something they've never dealt with. And then we've got on top of that the actual workloads themselves are sort of significantly more resource hungry. So, than traditional applications. So we're dealing with this different model. We're dealing with a different compute model, a different distribution model, and a different interaction model. And all of this is dynamic. We don't have these fixed predictable patterns. If we start sort of thinking into a true agentic perspective, we're making adaptive changes based on the information. So we need to understand what's happening. All of this is why the industry is sort of changing at this rapid pace. We're starting to deal with this complete new infrastructure with all these elements thrown in at once.
What steps can organisations take to assure performance while integrating and deploying AI?
So the first thing is we've talked about this changing landscape. So we need to be able to understand where that is from an infrastructure perspective, understanding our entire digital footprints from the users of the application. I need to be able to understand all these different third-party dependencies. We can't just consider these assets to be static. So we actually need to be able to do this within a dynamic environment. Then we need to consider a look from where the AI and the non-AI workloads are going. So we're not completely going to an AI-only world. We're still going to have these non-AI workloads. So where are they going to be located? Where are resources going to be located? Can they coexist in terms of sharing resources? How are they going to be accessed? Where are the user base? Are we going to have any impacts to those? And then you really need to consider this scaling strategy. Remember, we're dealing with this dynamic environment. We're never going to have a set and leave scenario in here. So we've actually moved away from that, where we're now really starting to say, okay, I need to scale horizontally and vertically at the same time. So I need to stretch out, I need to stretch Armstrong and stretch these things out from there. But I need to be able to do that dynamically, because I not necessarily need those resources all at once. It's when something's coming in. And more importantly for all of that, and this is where that visibility across my entire infrastructure starts to come into real play, is that I need to make sure that these are always available. So we're coming from a resilience perspective where it's not just that they're up, but they're actually performing. So because if I actually drop one part of this service delivery chain now, it doesn't necessarily mean that the system is going to fail. It might mean that I miss valuable data that allows me to make another decision.
In addition to hybrid environments, you mentioned that distributed architecture will also likely be part of many organisations' AI strategies. Why is that? And what are the performance challenges to consider?
The why of that is really because of what we've talked about in terms of we're going to have this distributed architecture. We have all these different issues that come in place. At a real base level, AI will always perform better when it's close to the data sources and the users themselves. So we want to reduce latency to reduce that response time. It's no good waiting for a response there. So what that drives is this edge computing. So we're going to have this moving out to the outside. When we talk about the hybrid type environments, we also consider, again, considering where our data sets are going to be, there's this evolution towards like a data center in the box where you need to improve your ability to deploy AI models to the edge devices for better performance, but also to meet some of the regulatory requirements you actually have. And then you have this performance challenge, right? This complexity. So now we have this multiple distributed environment. We have these edge compute resources. We have some centralized. We have some in various clouds. We have different parts there. We maybe have a user base distributed. We might have one agent that's actually in a different part of the world. So we have to sort of manage performance across this multi-distributed environment as well. So we need to be able to understand to put that together. So we're no longer now monitoring individual elements. So we need now to have this, not just a holistic perspective, but this in-context perspective so that I can dynamically adjust to where it is. It's no good me just suddenly saying, okay, yep, I can actually get to that point. It's available, it's available, it's available, it's available. If all of a sudden my data set's moved or I've actually done replication or I've actually gone to a different agent, because of some of the input I've actually got from there. So I'm no longer now monitoring to that point. It's like essentially sort of monitoring to a streaming service and saying, okay, the front end's up, I can get to that. But what's happened in another part is the actual stuff that feeds that content down has gone down. So it doesn't mean anything at all. And the other thing to this as well is we've got to this stage now. We've always said the network's important and the contextual glue that allows all of this to run. But this is now more than ever. So now we have this real heavy dependence on the network, and it's actually shifted from this, can we have connectivity, to can we perform? And this isn't just data integrity in terms of sort of the quality of the data that's coming across there. We could have delayed responses, so it's performance as well that starts to come in. What I'm saying there is it's actually a delay or a loss or some sort of quality issue when we're actually retrieving some part of the data. Then we have this issue where we've either missed a subset of data or we're lacking information, or we've gone into a halt state on a particular process as well because we physically couldn't receive it. So effectively, if we're talking about connectivity, that is now table stakes, and it's performance and the assurance of the delivery of the service on top of that in this dynamic environment, which becomes critical.
Tell us more about how AI changes how we think about digital resilience.
AI introduces unfamiliar scenarios where these systems have to interact together, and where traditional resilience and planning didn't necessarily account for. So we have these unpredictable performance patterns. So the decisions create these unexpected system behaviors. We may see something that consumes resources in one particular area, but not in another. And that may shift from day to day, from hour to hour. So we have this constantly shifting dynamic pattern that we've had that we've never seen before because of all these moving parts. On top of that, then you have sort of these third-party dependencies. So now we're even more reliant on these external networks and these services, because it could be a crucial function within that system. So yes, I might have my main source of my data within one particular area, but if I need to go and pull a resource that's from somewhere else that has this critical information as well, I need to get that in a timely fashion. I need to be able to pull that data down. These are outside of your control. On top of this, when we're thinking about this resilience, like I said, if we actually think it beyond the connectivity, we've got to be able to understand and effectively mitigate these cascading failures that can occur. So if you have a system failure in one part, where we've seen it before when we're dealing with one particular application or one service, it may stop the service working or it may have a particular function with that service working. Obviously, that has an impact. We have these dependencies and disparate dependencies. And what I mean by disparate dependencies, these are potentially agents that you only call once in a process, or you might not call on a regular interval. So therefore, that isn't part effective of your daily service delivery chain, but it becomes dynamically part of it. You now have this importance. I need to know that that is up, because when we use it, I want to know it's there. So at some point, it's actually been part of our service delivery chain. So therefore, it's separated from my overall service on a regular basis, or what I consider to be a regular basis. But I still need to know it's going to be there when I call it. When I make that request for information, then we actually start to get it back. And because of these interactions there, we have potentially this broader impact scope. So we can now affect multiple business processes simultaneously. Because traditionally, when we're considering a service, it might be an ERP or a CRM type of service there. Yeah, that might be used by one department or one area. Or we have the broader ones when we talk about Office 365, for example. But now, because of the way this system is set up, they're effectively all intertwined. So I could have a single failure that could almost impact several businesses. Whereas in the past, like I said, we might have actually just hit this one group of users. The impact's footprint has the potential to be much wider.
It sounds like spotting performance issues can be much more difficult in this new AI era.
So because of all these different interactions that we're going to have in all these systems, it actually makes detection of issues far harder now, or increase that complexity. Because we have not essentially looking for hard downs or outages, or even these functional failures. We might have one particular system that's sort of running slowly, and therefore then we're not actually reaching that agent or that set of data we actually need to complete the task. We now need to sort of measure again across this performance perspective. So we're not assuming just connectivity or looking for this large out. We're looking for these slight degradations. So this is when you now need to start to talk about the quality of the data in terms of the performance, the delivery, and then really thinking about sort of what we're actually getting out from that system as well. This ultimately shifts everything from this break-fix mentality. I can't therefore afford to be in a break-fix world, because once it's actually gone down, because of that large footprint potential I have, because of the slowdown, the degradation in performance, the quality of data issues that might occur, as well as the cascading sort of stuff there. If I actually wait for that to happen, the impact could be far great. So what I've got to really start to do is to move truly into this predictive state. So I really start to understand, well, where is it going to go? We talked about the dynamic nature of this. So what do I actually do in this environment? So this is then where I'm talking about why you need to have this visibility into these disparate dependencies as well at the same time.
Tell us more about performance problems that can occur if organisations aren't AI ready. What type of outages or disruptions might companies experience?
The one that really comes to mind is that cascading performance degradation. So we have this slowdown sort of coming through. Now, this could be because we have ineffective resources, or because what we've actually done, we've just done a lift and shift when we're actually thinking about this, and we're starting to get sort of these delivery failures themselves. And again, because they start to come across the whole environment there. So then, what can actually cause these? Because we have all these different parts around there, we have potentially this sort of resource starvation. So if we think about an AI workload, it can monopolize the CPU, the memory, and the storage, sort of starving the traditional applications. So we might be running along very well with our AI system, but all of a sudden this coexisting traditional application, as it were, is starting to have this degraded performance. And this might be even an element you're actually calling that again, you have no control over. So you have this sort of effect that you have no visibility into or way of controlling. It's starting to run slowly. What this essentially leads then to is instability in infrastructure itself. So if I'm actually unprepared, I haven't been able to scale this properly, then I could have crashes. The trouble with a crash is that it's going to have this ungraceful shutdown. And you also then, we're not talking about monolithic architecture. We're now talking about this distributed architecture, even for our traditional applications. So what that then happens is then we might lose a part. So the recovery process to that takes longer, because we might have to go and rebuild the database to actually get the system back online, to restart a system itself. So it becomes really important then from this scaling perspective to understand your compute resources alongside how your system's performing, so to have that direct correlation between the two. So when we think about it from an end user perspective, essentially what they're going to face from all of this is a slow application or failed transaction or system unavailability. So then obviously this impacts the overall production itself. And it might not be on specifically AI application or the task of actually looking from there, as there could be this adjacent application or this business application you actually need to use. This has moved on from when we're talking about resilience in terms of keeping the lights on. This is actually keeping the lights on and things performing, so productivity itself.
Finally, Mike, do you have any tips to leave us with?
Top of mind is AI readiness is a journey, not a destination. So continuous adaptation is essential. It's not a one-time infrastructure upgrade. You're going to have to constantly look at this and sort of change it. Then I'd say embrace hybrid thinking. So plan for AI and traditional workloads to coexist rather than replacing everything at once. Look for that sort of scaling environment. Scale as you go. So test before you scale, implement these testing processes, understand what the AI workloads are before moving from pilot to production. Don't just think I can actually do this straight change. This is not what we've done before. But do learn from your cloud transformations. So apply these lessons we learned from the cloud migration. We sort of saw that a lift and shift doesn't actually work. Think about the functions, think about the architecture, and sort of adopt those as you go to an AI strategy there. Then I'll say sort of future-proof with flexibility. So build your infrastructure that can adapt. We talked about that east-west and that north-south elasticity. So adapt to an unknown future. We don't know where it's going to be, but we have to be able to not lock ourselves into what's happening now, but be able to adapt to sort of AI innovations requirements as they come up.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.